In my last video, I spent a little bit of time just sharing my thoughts about how I'm going to work through the different decode logic so that both my 286 and my VGA output can access the appropriate memory. And I've been organizing that memory into a frame 0 and frame 1. And up to this point, if I go to my schematic for a second and I zoom back, I've started the work on this device here, which is this PSOC that allows me to do some miscellaneous decoding just to decide or help control which chips are enabled to win. I had previously connected up one set of the multiplexers to my frame 0, and then I had connected up a set of transceivers to get the data back into my 286, along with previously connecting up this 16-bit register. In this video now, I have added in the rest of the missing pieces here. So I've added in the additional multiplexers for frame 1. I've also added multiplexers for the output to go over to the VGA out circuit. I've also added the transceivers for frame 1 to get back to my 286 data. And I've come in up here to this PSOC, which generates all of my VGA counting and addressing and sync signals, and have updated that accordingly. And then over to the right, I have my VGA output, and I've connected all of this into my actual breadboard version. Maybe one quick note, I did add one new thing to the schematic that was not there before, which would be another pair of transceivers. And I did this really because coming out of my memory, frame 0 or frame 1, I have 16 bits of data, but my VGA out is only expecting 8. So I'm going to read a word, but I need to be able to output a byte to the VGA output. So I'm just using these transceivers to toggle based on how my video address 0 is set. If it's a 0 or a 1, even or odd in other words, I'll then output the appropriate byte of data, the high byte or the low byte, out. And I think there's other ways I could approach that, but for now, that's how I'm doing it. And it might be down the road that I get rid of these transceivers and I add another 273 over here and go for a 16-bit color output instead of 8-bit. And honestly, the way I'm set up right now, I could probably make that change pretty easily. I've got 16-bit capable coming in from the 286. I have double the memory I need in both of these frames. I've got a meg and I'm only using half a meg. So I could go to 2 bytes of color data per pixel, still fit it into everything I think here pretty nicely, and really have minimal changes other than taking out a pair of these transceivers. But I'll maybe come to that later. For now, 8 bits is plenty for what I'm trying to do, but that is some flexibility that I think I have down the road. So looking at the breadboard itself here, let me just point out maybe where I'm sitting with this. So this was frame 0. These were my multiplexers coming in. I've now connected frame 1, the pair of static RAMs, along with their multiplexers. All of the appropriate addressing signals coming from the 286 are making it to both sets of multiplexers. The VGA out circuit, all of its addressing is coming out and going to both set of multiplexers. The output of frame 0 and frame 1, they both are going through their appropriate transceivers to get them back to the data bus on my 286. I also have the appropriate logic up here for my register, my 32-bit register, along with transceivers to get that data back out when I want to read from it. And then I come down here and I have a set of multiplexers that lets me choose frame 0 or frame 1 for the output to my VGA circuit. And then as far as my VGA circuit is concerned, I then go through these extra transceivers that I was talking about so that I could pick the low or the high. And then the output of that is going through a little common bus here over to this 273. That then gives me my red, green, and blue signals coming out of it. And then I've set up my resistors a little bit differently. And here on the screen, you can see how I currently have that set up. So I have a red, 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 green, 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 blue, blue, but I've changed the resistor values from a 270, 561K. I repeated that for the green, and then for the blue, I have a 220 and a 470. Plus, I pulled the combined outputs down with a 150 So this 150 is going down to ground. But that's where I'm tapping it into my red, my green, and my blue, my RGB into this VGA out. And then of course it's pulling its sync signals, vertical sync and horizontal sync from this PSOC over here. I did have to invert one of the signals just because I needed these two on opposites, A0 and an inverted A0. And I did not want to run all the way up to an inverter. I have a 14, an HC14 sitting up here. I didn't want to run wires all the way up and all the way back, so I just put another one in here. Whereas on a PCB, this one won't be necessary. I'll just use the other one. But I wanted to keep these runs short and as away from everything as possible. So that is where I'm at, and then I've done some initial coding just to do a really simple test here. What I want to be able to do is output not just an uninitialized output of RAM to my monitor, which would show up as kind of a snowy, a white noise type effect because it's random data in that. I wanted to initialize that to all zeros, in other words, just write a black screen. And I also wanted to see if I could write an all white screen just to make sure that I can fill in the screen. And I want to be able to not only go to a frame and run through all of its segments, I want to go to the other frame and run through all of its segments. And what you're going to see here is I set on boot up, I'm going to set this frame to black, I'm going to set this frame to white, and I'm going to tie my F12 key on my keyboard to be able to manually toggle the output from one frame to the other. So when the system boots up, it's going to initialize, it's going to set this to black, and while it's writing that, it's outputting this frame to the screen, which will be white noise. Then it's going to toggle and output the black to the screen while it fills this in with a solid white, and then it's going to toggle again. But then at that point, as I press F12, I can manually toggle those. And those toggles are happening on VSync, so I do have it tied to VSync, and I'll show you real quick how I did this on the VSync. If I flip over to my PSOC logic for a second, I modified it a little bit from the previous video and a little bit from previous discussions, but I do come in here and I have this basically this item right here that's letting me go in and use a D flip-flop. And if I pull this over, so I now have this D flip-flop that I have on my schematic right here within my PSOC, and this is the address decoding or the decoding PSOC. And so that flip-flop is tied to my vertical sync. And so as the vertical sync happens, if I had previously tried to change the output from one to the other, the 286 gets one, the VGA gets the other, I can change the register to say, nope, flip that. And when I flip it, it doesn't flip instantly. It waits until it gets to the VSync signal. And so that's what this is doing here in this PSOC. I'm bringing in the sync signal, I'm bringing in the register, and then I only flip it at VSync if there was a change. But now I came in here and I added in this exclusive OR, and basically I'm saying look at the register and look at what is actually being output from this flip-flop, and if they're different, give me a signal here that just is a high. So now I have a really easy way to tell that I've changed the register, but the actual output hasn't happened yet because I haven't gotten to the VSync. But this is an indicator I can now use from code. And I'll go show you some of my 286 code here real quick that I'm going to do on boot up. And let me zoom into this. So if I start out maybe going up towards the top of my code, I have added a call to, I'm just calling it VGA temp. Now on boot, I am still on the post test, writing to and reading the VGA register just to make sure I can do that successfully. And I'm still writing to frame 0, the first segment, the first 64K, just to make sure that works. That's the only thing I'm doing on the power on test as far as the video is concerned, and I can expand that later. But for now, what I did is I added this VGA temp procedure, and in it, I come in here and essentially fill all of frame 0 with black, and that's just putting a word, a 0, 0, so a black and a black, so 2 pixels in a row, writes it, goes to the next memory location down, writes it, kind of fills it from top to bottom. But that's all within the first segment, and then I come down here and I pull in my register. I then, basically filter out the bottom 4 bits, which is which segment I want. And then I really or add to that CX, and CX is just a counter, and every time I go through a 64K segment, I increase the counter, I do the loop again. So this loop essentially just lets me go through all the 64K segments for my video output on here. So I just simply go through that 8 times, and that's the first 8 segments of this 1 meg, which is enough to cover my VGA output at 640 by 480. When that's done, then I do a loop again, and I set everything to white. But before I do that, I swap frames. So here's the code where I say basically this bit right here, flip it from a 0 to a 1. So flip to the other frame for the 286 access, which automatically then will set frame 0 as my VGA output. And I do that. And I have then a real quick little loop that just says pull in the register, test this specific bit, and that's the bit that corresponds to this PSOC output, which is frame switch pending. So it looks at that, and essentially if that is a 1, it just stays in this loop until it's done with that, and then it pops out and continues on. So that's how I can safely know that I can continue writing to video memory because I've made the switch, the output is working, etc. But then I fill in the white, and then I go ahead at the end of the white, just leave it out as that on my output. Or actually, no, down here I do flip it back, and then I do another wait. So I'm going to write white, I'm going to write black, show it, write white, and then flip it and show it. So that's what I'm going to do basically when I turn on the system. And then I'm going to scroll down, and in my keyboard handler, I'm just going to scroll down to where I do my F12 key. So here's where I check for F12. So if I hit F12 on my keyboard, basically I'm going to print out the character to my little LCD so I know that it recognized the F12. That's not a big deal. But then I'm going to go ahead and read in the register, and then I'm going to toggle the bit right here. That is the bit that says which frame is the 286 reading. Now when I toggle that, the output to the VGA toggles at the same time. That's automatic in my logic. And then I output that. And then I wait just to make sure that I have hit VSync before I continue on. I do have a delay down here, and this is more just for the F12. I was getting maybe some duplicate F12s when I was hitting it, so for now I just put a delay in to get rid of that. That's more of a keyboard handling thing than anything to do with this video. But this here is really what's preventing me from writing to the wrong frame. In other words, updating the register, proceeding with a write before the VSync has actually occurred. And so now this generic loop I can add in anytime I decide to change frames. And of course, I'll make a procedure later that does the frame change and does the wait all in one. So I can just say call, toggle frame or something like that, and it'll do all this. So that's what I have there. And I think what I'm going to show is I've got one camera here on the actual screen right here. And then I'm also showing you this video here, but I was using my little VGA capture, and I was getting a little bit of lag with it. So for this video at least, I'm going to just show the actual VGA monitor output. So system's off. I'm going to go ahead and turn it on, and I'll probably go through this a couple times, but it's doing a normal computer RAM test. You can't read this, I know, but that is after the RAM test doing a VGA register test and then a VRAM test of that first 64K of frame 0, and that passed. So that gives me some confidence that I'm getting over here and back. I should maybe comment, I am running a 32 megahertz oscillator, which means 16 megahertz is my overall system bus, and then the processor internally will be running at 8. But when it went through that, what I want to point out, I'm going to reset. Watch if you can see, hopefully you can see these bar graphs over here. The very first LED is that I'm waiting for a VSync to toggle. So I've asked the system to toggle my frame based on the register. And if you see this very left LED light up, that's where I'm saying I've asked it to change, but I haven't gotten to VSync yet. So you'll see that. And then you also see the lower 5 bits. The lowest 4 are which segment is it currently reading from the 286. And then the 5th bit, the next one over, the 5th from the right, is which of these is actually being output. So it's just helping me know which frame I'm on. So when I reset this, it's going to go through my normal RAM testing, then I'll see it gets over into the VRAM, and there it went through one frame. I saw it toggle to the other, so there was a momentary wait for the VSync, and then I saw it flip through the other frame. So I'll do that again if you want to watch that. But it's going to flip through my segments, flip to the other frame, flip through the segments, and in between both of those you saw that quick little pulse while it was waiting to flip frames. And you can see on the output now I've got my white screen. So I'm going to go ahead and reset one more time. When it first comes up here, now in this case the RAM has been initialized, so it's coming up, without all that snowy effect. So let me turn off the system and give it just a few seconds here. I'm going to turn it on, and if you watch the screen, I think you're going to notice it comes up with the snow first. That's the uninitialized RAM. And then there's my white, or my black, and then my white. And at this point I should be able to press F12 and just toggle. And as I toggle, I can see on the bar graph down here which frame I'm outputting. And so I can toggle back and forth, and I can see that VSync signal as I've asked it to make a change, and it's waiting for VSync to catch up to actually make the change. But in this case, I'm just toggling back and forth. And if I look at the output, definitely there's noise in this. And if you look at this mess that I have here, I think that's probably to be expected. I've got wires all over the place. They're crossing all over. I'm running a full 25 megahertz, clock on this wire all the way over. I'm going through, I guess other things. I've got my pixel clock. I've got my VA0, so video address 0, which is a fast moving signal also. I'm running that over, plus I'm running an inverted version over, so all that really high speed stuff I think is pretty much staying down here for the most part. I do also run some of that up here. But with all of this, I was actually surprised on Fire Up. It pretty much was where I needed, minus I had to add those two transceivers for the low byte, high byte. I had kind of overlooked that, and so I came back in and quickly added those in. But so far, this appears to be working fine, and I'm not worried about that noise, because I think that's just the nature of a breadboard running a 25 megahertz pixel clock on it. But this is working, and I'm quite happy with that result. And so what I plan to do next now is I've got to get in and just do a whole bunch of assembly and start writing some structure so that I can treat the entire screen as a logical width and height and pixels, and have it within the code automatically figure out what's the right segment within the frame that I need to then change colors and things like that. And I'll go back and revisit my code for typing characters, get that updated to work with this new setup. And then I'll start testing, just some colored output, not just an all black or all white, and see how the colors look, and see if these resistor values that I selected based on a reference I found on the internet, if those are better than what I had before. So I think that's it for this video. More to come, but I'm pretty happy that this is working on the breadboard. It seems to be behaving the way I was hoping it would behave. And now I need to do some testing and see, can I really write things to it the way I want to? Can I start doing some animated content where I write one frame while one is visible, and then I swap them and make more updates and swap them, and can I make some animation go across the screen, and how well does that perform or not perform? This has given me enough indication that I think I can probably order, or I'm close to ordering, maybe a PCB version of this, so that I can do things like quickly swap out the ICs with AC versions instead of HC versions, and maybe do some other things. And I am finding a lot of value in this little bar graph output, so I'm probably going to take away these temporary wiring and put in more of a laid down wiring, just because that is kind of handy. As I do a reset, I can see where I'm waiting for VSync. I can see which frame is output. I can see which segment I'm currently working in within a frame. and that's all pretty handy. Thanks for watching, and I look forward myself to the next video where I've got some more coding and maybe some useful output on this instead of just plain old white and black.